Hi friend, today we're going to continue with our project and we're going to make the printed circuit board. We're going to get it ready for manufacture. First thing we're going to do though, we're going to go to File, Export, and we're going to export a bill of materials for all the items we're going to need. So that's what we're going to do. We're going to hit Parts, Text. We're going to save that. Let's put it on our desktop so we know where it is. Now if you look at it, it has all the parts. Now you'll notice it also has the ground pad and the LED pad and the 9-volt where we attach the power supply. Just ignore those. What we're going to do is we're going to make this shopping list for when we go to pick everything out. All right, that's good. Let's go back to our schematic. This is one of my favorite things about Eagle. Once you make the schematic, it knows what parts you need. So you go to this button right here. That is switch to board from the schematic. Would you like to create a board from the schematic? Absolutely. Let's do it. And here's what we have. What we're going to do is decide which enclosure to put this in. We could put it in a tiny enclosure like the 1590 LB, but we want to put a switch on this one. So we're going to put it in a 1598. Now this is still small. You fit a bunch of these on a mini board. One of my favorite ways to build is small. So best part about the Mad Bean library that we downloaded. You go to this enclosure right here and look at this. It has them. And you lay it down on your circuit board area and it tells you where you could place your components. It's awesome. Let's start placing these on here. It takes some getting used to how to get these to move. Sometimes you select the name and it pulls that on there. If it starts to do that, just hit escape and it'll go back. And what you have to do is right click and then left click again. And what we're going to do is we're just going to drag these all over into this area here. You know what? Let's grab them all. And we'll move it just to make this part faster. All right, I want to make it a little bit bigger. See, the only downfall of putting this in here is that what it does is it zooms into that when you hit the zoom to fit. So what we're going to do is we're going to move this dimension so that it just fits inside here. All right, now we can get rid of this. And now we have everything we need. We can make these. All right, now let's make this bigger again. And this is all the width we have. We still want to make it smaller top to bottom, but we'll get to that as soon as we can. So I'm going to start placing these on here. This is our 9-volt. Not on move again. Why not? We're going to put these up towards the top. Ground. And when you right click, it rotates. So it gets the labels out of the way. And we want this to be here's the thing. The way the potentiometers are, we could put this over because this is just silkscreen for the printed circuit board. This is the electrical part that we have to worry about. And you could put that over top of anything. All right, I'm going to fast forward this and start placing these items. All right, when I put an item on the printed circuit board, I like to hit this rat nest because it simplifies where we're at. And I like to put everything as close as possible because that makes it so that we can make this as small as we can, and that way it keeps the cost down. Now this is the output, so we're going to put that on this side. See how you can't get it right between those 2 points? What you want to do is come up here and make these about half of what they are. Oop. Now let's try that. Ah, much better. I'd like to hit rat nest every time I add something. Okay, we want the switch to line up with the diode and the potentiometer. So we want all three of these to be on the same line here. Looks good. All right, I'm going to group all these. Let me trash these. Let's group all these. We're going to move that down all the way down here. Whoops. Okay. Now what we're going to do is bring this dimension down right over top, right where we need it to be. What this does is makes the printed circuit board as small as possible, which is what we want because, okay, what this does is we want this printed circuit board to be as small as possible because it's a cost issue. The smaller the board, the less it costs. If you ever make a mistake and you just want to start all over, just go up to the command line here, type rip up, semicolon, hit return. It'll ask you if you want to rip them all up. Now all your air wires are back and there are no traces. We're going to do something first that I should have mentioned. We're going to make a ground plane. I like to make the ground plane on the bottom. Just a personal choice again. What we're going to do is we're going to select polygon. And we're just going to draw a square right around our printed circuit board. And when you complete it, you're going to call this GND. That makes it so that it's electrically equivalent to all the grounds. Let's see. And now when we hit our rat's nest, watch this. It makes a ground plane, and all the places that were grounded are already connected. See that? Now, here's another thing we're going to do. We're going to go to OshPark and download this 2-layer design rules check. We're going to put that in Documents, Eagle, Design Rules. See, I have it right there. That way, when we're making our PCB, we'll right click on this, load it into this board. Now watch what happens when we hit this rat's nest again. Gives us a lot more room because Osh Park has the ability to have finer details. So now all we have to do is connect all our air wires, and now there's a lot less. There's only 27 to connect because we took care of that. And we could also look, see right here, we're going to move these down a notch because there's room for it. And it'll get rid of this open area. There, how's that? All right, now I'm going to fast forward this and connect my air wires for real this time. I'm going to go to the top layer again, select my routes, and I'll talk to you in a few minutes. Okay, when I do my signal traces, I like to go back to a smaller route, a smaller trace. So I'm going to go ahead and do that. Okay, watch this. When I go to connect this to this, there are a lot of top traces there. So what I'm going to do is I'm going to go to my bottom layer. That way I can go straight across. Now watch when we do the rat's nest, it actually cuts the trace out of the ground plane that we made. Now you have to be careful with that. See, places like this right here, when you look at that, if you cut a trace like, let's say I was going to cut a trace like this. You have to be careful because you could isolate these grounds and they're not connected to the other grounds in the circuit. All right, just make sure you check that. Okay, here's something interesting. There doesn't look like there's a very good way to get around this. So we're going to go over to here and see how I can't get through there. What we're going to do is we're going to hit the space bar. And what that does is it flips the trace from the top to the bottom. And it goes through what is called a via. See that little, what that does is it makes, basically looks like a solder pad, but it connects the top layer to the bottom layer so that you can make a trace that connects between the two. So that's what we're going to do. See when you hit your rat's nest, see how it goes from the top layer over, stops there, and then goes to the bottom layer. All right, let's continue on. right. Looks like I got it ready to go. And what we're going to do now is we're going to go back to Osh Park. I don't know if it's Osh Park or OSH Park. I don't know. All right, once we get our board completed and we hit the rat's nest, it says nothing to do. Perfect. We're going to run that electrical rule check. No errors or warnings. We're also going to run the design rules check that we downloaded from Osh Park to get the rat's nest to look correct. So all we do is make sure it's selected Osh Park 2 layer and hit check. No errors. Perfect. Now if you had something like, let's make an error. Let me move this so it's just a little bit too close to that trace. Now watch what happens when you run that design rules check. See, it'll say there's an overlap, and it'll even show you where it is if you double click it. Let's undo that. It also tells you if your pads are too close to the edge. You can see the little red marks there. It shows you in advance, but this just gives you something to check to make sure everything's right. See, your dimensions are not correct. Okay, so let's undo that. Save it. Right here, no errors. Perfect. Now we're going to upload it to Osh Park. What I do is I click this browse for files. It's under your documents, Eagle, projects, and there it is right there. Here's your board. Upload this file, and we're going to watch, let it process, and it'll give us a price right away. Probably right away. Ah, there it is. Look, you get 3 copies of this board, professionally made, for $7.55, and that's shipped. Let's call it NPN Rangemaster. You can put this description in here, but that's only if you want to share it. So we're going to continue this. Now this shows you everything you're ordering, so you could look it over and make sure everything's correct. Gives you the drill sizes, bottom silk screen, top layer, top silk screen, layer mask, bottom layer. And you go down to this bottom and you hit order. $7.55. And we're going to hit checkout. Now I'm going to go ahead and order this. Grab my credit card. But don't look at this. These are my numbers. Now you see if your USPS is free shipping. Estimated time of arrival, 5. 5 something. Most likely it's 5 working days. Let's complete our order. Okay, now we're going to go through our shopping list. I just went through this once and discovered I didn't have my microphone on right, so it didn't come out right. So I'm going to do this quicker this time. Basically what I'm going to do is go through all these websites and order the parts that I need from this list. I'll just show you the order that I go. My first stop is always Tata because the prices are good. I'll show you what I got in my cart so far. Whenever I order resistors, I usually order packs of 100 because they're usually 1 cent each, or right now it looks like they're 1.2 cents each. So 100 resistors cost $1.20. So I order a bunch of what I need for this build and let them roll over to the next time. As you can see, I got 100 of these 3.9s. Oops, that was one I accidentally ordered. I wanted a 3.9K. Make sure you get the right one. These resistors here, 1 meg, and then I got my capacitors. I get the film capacitors and the electrolytics, and surprisingly they also had the germanium diodes. They're a little more expensive, so I just got 6. The 1N4001s are 2 cents each. I get 50. You could go through their site and get any of the LEDs that you want. I chose the blue water clear. I may change my mind when I place the order, but after I get everything that I can get on Tata, the next one I go to is Love My Switches, and I get my enclosures, I get my foot switches, I get my toggle switches, and I always get my 1/4 inch. I always pick the Lumberg jacks. They seem to last longer. I also get my power jacks too. You're going to want to pick the 2.1s. That's the normal ones that everybody has. I usually get 10 at a time when I order them. You always need them. For every pedal you also need 2 of the mono 1/4 inch jacks. After I go from Tata to Love My Switches, then I go to SmallBear Electronics. They usually have some different items. They do have some germanium transistors, but not the one we wanted. You can still buy one from them, but where is my cart? What I ended up ordering from them was the 9mm right angle 10K audio taper potentiometers. That was the only item that they had at the moment. And after SmallBear, I go to Pedal Parts Plus. They always have nice transistors. I really like the 2N388s. It's really nice. They also had the 0.005 microfarad, that's 5 nanofarad capacitor. I ordered 6 of them. They were 21 cents each. After that, if I can't find things on those sites, I'll go to Mouser. If you want to build something to sell, you'll find that the resistors have thicker leads on them from Mouser. Name brand items. The name brands from Mouser, you could probably get higher quality items. The WEMA capacitors are nice, but I also noticed that Tata is beginning to sell the WEMA capacitors. Let me see here. Let's see. You'll notice that the 1 nanofarad capacitor here is 9 cents. The WEMA version is 16 cents. 5 cents more per. Not a big deal. They're very good. They don't leak DC as much as the other ones. If you want to get the WEMAs, that's good. Go ahead and do it. But Mouser's my last stop. Nothing against them. It's just that the prices are higher and their shipping is higher. When you print out this bill of materials, make sure you don't forget your 1590A enclosure and your 3-pole double throw foot switch. I didn't want you to forget those. What I do is when I put them in my cart, I take that item off. And if I have a blank sheet at the end, I know I'm good. All right, that's what I want you to do. Place your orders. Watch out for shipping. If you could combine 2 sites into one, if you could get something on another site so you don't have to get anything from one of those sites, it's always better because the shipping cost is where it gets you. All right, I think that's it for today. really appreciate you stopping and watching. Give me a like. Please subscribe. It really helps me out. And I'll see you next time. What we're going to do next time is prepare the enclosure for when the other items come. If you don't have yours yet, that's fine. You'll still follow along. All right, I'll talk to you later. Thanks.